All right, now a little bit of fun stuff. So, what are some properties of acids and bases? So, an acid can be neutralized by a base, whereas a base can be neutralized by an acid. They are both electrolytes, meaning that they dissociate into ions in solution. Um, Important thing about acid is something that we did in the Unit 1 lab, which is that when an acid reacts with some metals, it produces hydrogen gas, whereas a base can feel slippery because it reacts with your skin and fat to make soap. If you were using litmus paper to determine if something was acidic or basic, then litmus paper turns red with an acid, where it turns blue with a base. Acids, if you were to taste them, which the only acids I would taste are like vinegar and lemon juice, but they taste sour, whereas a base tastes bitter. Now, you're not going to be tested on any of those properties, but they are some things that are good to know when you're leaving a course and needing to have a basic understanding of chemistry. Another thing that's really important is to be really familiar with some of the most common acids and bases. So, what I want you to start using is something called the relative strengths of Bronston-Lowry acids and bases table. So, sorry, I'm just shuffling my papers around. In our information booklet, we have on page 7 this chart, and it's called the relative strengths of Bronston-Lowry acids and bases. Now, don't worry about the Bronston-Lowry, you're going to learn it in another lesson. But this is a good place to go if you're ever unsure the formula for an acid or the name of an acid. So we're just going to go through right now and use this for the most common acids, but we will be using this entire table. So, for example, if I asked you for the formula of sulfuric acid, you would just go to the table and find the word sulfuric. Now, these are not alphabetical because they are listed by strength of acid, so you do have to do a little bit of looking around. But sulfuric acid is H2SO4. Then the next most common, hydrochloric acid, that's one we use a lot. So hydrochloric acid is just your HCl. Then we've got nitric acid versus a nitrous acid. Nitric acid is HNO3. And then we get a little bit more complicated. Where's acetic acid? Now, oftentimes, acids will have more than one name. So acetic acid is one of the common acids that we use, but you'll notice down here, this is where it's listed, and it says ethanoic and acetic. So this can go by either of those two names, and its formula is CH3COOH. Now, it's also good to be familiar with some of the properties of these common acids and bases. So, one thing I'm going to encourage you to do is go to Hebden, page 112. And in here, it's not that you're going to be tested on any of this, but it's just sort of good chemistry knowledge, is that you can go in and learn about some of these common acids and soon to be bases. So, for example, if I look up acetic acid, it is D. Commercial names is also, guess what? Vinegar, right? Properties is it's actually a non-electrolyte when concentrated. It's a weak electrolyte when diluted, only affects highly reactive metals. So it's kind of nice. It's not super reactive, which makes it a pretty benign acid. Its common uses are for making acetates, food preservation, for example, if anybody pickles, and also manufacturing textiles and plastics. So who would know, right? That something called acetic acid could simply be vinegar. All right, let's go through some of our bases. Now, these bases are not listed in your relative strengths of Bronston-Lowry acids and bases. They list the acid name until you get to the bases at the bottom. But the nice thing about a base, because of the Arrhenius definition so far, is that you know that sodium hydroxide is a base. So sodium hydroxide would simply be a sodium and a hydroxide, whereas potassium hydroxide would simply be a potassium and a hydroxide. And then ammonia is that's a little bit different, but ammonia, because it is a base, is listed at the bottom. So you'll notice down here the chart's a little bit different, which we're going to talk about. So up here we've got acids going to their electrolytes, whereas at the bottom here we have these electrolytes forming bases. And so these two at the bottom are actually base names. So anything that's a hydroxide ion, so sodium hydroxide releases hydroxide, potassium hydroxide releases hydroxide, as well as ammonia. So ammonia's formula is this NH3. And it's good to kind of get straight in your head that ammonia is different than ammonium. So ammonium ion is NH4 plus and it's listed as an acid, whereas the ammonia is listed as a base. And we're going to be talking about that in some further lessons. So I'm going to leave that with you for now. So in the homework, it's simply just to read about these common acids and bases and do some practice questions around them. And then we are going to look at the fact that, wait a minute, we called this a base, but it doesn't end in hydroxide. So it doesn't fit the Arrhenius theory of an acid. Lots more of that to come.